Alright guys, today, so as I said before the previous video, we're gonna do something about derivative. And so let's see the problem. 17 to 18. Use the alternate form of the derivative to determine whether each function is differentiable at a given x value. They verify that function is continuous at x equals to c. So for the first one, we have to know what is the alternate form of the derivative. So alternate form of derivative is limit as x approaches to c of f of x minus f of c over x minus c. This is the alternate form of the derivative. Let's start the question. So for this one, c basically equals x equals to 2. So we have to do is limit as x approaches to 2 of f of x minus f of 2 over x minus 2. And then what we got is, so from the further step, I will ignore the limit notation, but in the actual test or AP exam, you guys have to put limit notation in front of every steps. All right, so it goes to 1 over x minus a half over x minus 2. And then we simplify the equation, 2 over 2x minus 2x over 2x over x minus 2. And then we got 2 minus x over 2x over x minus 2. And then we got 2 minus x over 2x times x minus 2, 1 over x minus 2. So this one, 2 minus x and x minus 2, they cancel out, they got negative 1. So we got negative 2x over 1 over 2x. Alright, so this one is our derivative. I mean the instantaneous value or derivative at the x equals to 2. And then we plug 2 to the function, and then we got it's negative of a quarter. So the limit exists, which means the function is differentiable at a specific point. So x is continuous at x equals to c. So this one is continuous. So the reason is the differentiable the derivative at the point exists. All right. The next one, f of x equals to x cubed plus 3x squared plus 4 at x equals to negative 1. So as before, do the alternate form of derivative, and when we got it, limit as x approaches to negative 1 over f of x minus f of negative 1 over x minus negative 1, which so x minus minus a negative value equals to plus itself, so which is x plus 1. Alright, so f of x is x cubed plus 3x squared plus 4, and minus f of negative 1, which is negative 1 cubed is negative 1, plus 3x squared is 1, 1 squared, negative 1 squared is 1, so we plus 3 and then plus 4 over x plus 1. So we got it's x cubed plus 3x squared plus 4 minus this one it's 7 minus 1 is 6 over x plus 1. So this one 4 minus 6 is 4 minus 6 is negative 2. Alright, from here on, many people would say, oh, it's hard to solve or it's hard to factor it out. So what can we do? Well, yeah, what can we do? So for this one, if you're not sure whether this function is factorable or not, we just do the long division. So long division is we put numerator and denominator into division, so which means x squared plus 3x squared minus 2, and it's divided by x plus 1. So this step means we have to try out whether the root exists at x plus 1. So we put 2x, so basically we see this x cubed plus 3x squared, and then we found there's no something about x, just simple x to the 1, x1, x to 1, x power of 1. So we found there's no value of x about x, so we have to do plus 0x and then minus 2. All right, so we plug x squared to x. So we put x squared to above, and then we got x cubed plus x squared, and then we minus them, which is 2x squared plus 0x, and then we got 2x and 2x squared plus 2x, which left us negative x minus 2, so it minus 2. So we found this function eventually becomes into x squared plus 2x minus 2. All right. So we plug negative 1 into it. What we got is 1 minus 2 minus 2. What we got is negative 3. So negative 3, which means our derivative at a point exists, which means when the function is equals to the x equals negative 1, the function is continuous. All right. So next question, from problem 19 to 23, use the graph of f function of f of x, showing the figure at the right. So the first one, what we have to do is find the f prime of 4. So f prime of a 4, it just eventually goes to its instantaneous value, which means the slope of this line. So slope equals to rise over rounds. So rise is 1, rounds is 2. So the slope is a half, and then we plug 4 to this function, to the slope, and we got 2. So this one goes to 2. The next question, for 20, for which value of f of x is f prime of x less than 0. So this one, we have to analyze each piece of the function, and we see how the slope of it, how the rate of change of it goes. So for this part, from 0 to 3, all right, so this one is just a horizontal line, which means there's no slope and there's no change, which means the derivative just goes to 0. For this one, it goes up, and which means the derivative is also positive. And for this part, I would guess it's probably like 3 from 5 to 7. For this part, we can see it also goes down. So this part is still positive. But for this part, when the x is greater than 7, it goes down, which means we can make an infinite tangent line of each point, and we basically see each tangent line is basically positive. So the derivative after x greater than 7 is negative. So which means when x is greater than 7, f prime of x is smaller than 0. Alright, shown that f prime of 3 doesn't exist. So for this one, you see the function goes from 0 to just suddenly become a positive value, which means the derivative doesn't exist. So it basically at x equals to 3, there's a corner in it, so which means it doesn't exist. But the question asks us to show that. So what we have to do is we verify the limit of we have to verify the derivative from left hand side and right hand side, right hand side. So x goes to 3 from the left hand side, f of x minus f of c over x minus c. What we got is f of x with f of x is 1 minus f of c. So we plug 3 into it, it still goes to 1, and then minus 1, and then x minus c. X minus So it goes to 3 minus 3. So for this one, we got 0. And then we do the right hand side. Oh, sorry guys. So just found a small mistake here. So f of x. So for this one, f of x. So it just goes to 1. 1 minus 3 over minus 1 minus 3, so which is 1. It's not like 0 over 0. So for the next one, we got the limit as x approaches to the right hand side. Alright, so we plug f of x into it. So for this one, I feel f of x is, so the slope is a half for sure, and then we have to figure out what is the intercept, y-intercept. So a half, we plug 3 to the function. So when it's 3, so when it's 3, the y value goes to 1. So 1 equals to 3 over 2 plus b. So b is negative a half. Alright, so half of x minus a half minus f of c, which is we got it's 1, and over x minus 3, x minus c, which is 3. Oh, sorry. So sorry, I'm really sorry for this one. I just noticed that. So f of c, it goes to 1. So which means 1 minus 1 is 0. 0 over negative 2 is 0. And for this one, we got a half of x minus 2 minus 1 over x minus 3. So then we got it's a half of x minus half of 3 a half, and then x minus 3. So we can get the derivative is a half. So basically the two limit or two derivatives, they're not equals to each other. So this point it doesn't exist. Or if it's continuous, if it's f continuous at 5, explain why or why not. So from this point, it's continuous. It's definitely continuous because it's polynomial. And so what we have to do is explain it again. So limit as x approaches to the from the left hand side, what we got is 2, and from the right hand side, what we got is still 2. So they equal to each other, so they are continuous. And which one is larger, f prime of 5.5 or f prime of 6.5? So for this one, I would say f prime of 6.5 is greater than f prime of 5.5, because for this one, the derivative probably goes up, because the slope of derivative it's positive, which means a greater x value will lead to a greater y value, which means f prime of 6.5 is greater than f prime of 5.5. So here's the video today. Hope you guys enjoy, and hopefully you guys coming out what problem I got wrong, or something mistake, or something concerned, or I mean confused, guys. So comment below and let me know. And tomorrow or on Monday, we're gonna do something more advanced about derivative. Alright, thank you guys for watching.